In the next two examples, we want to look at applications problems involving rational functions. In example 8, we're given the total cost function for a company to produce X units of a certain product. This is not a rational function. This is a polynomial function, a quadratic function. But in part A, we're asked to find what's referred to as the average cost function. This is a new function that we'll construct called C bar of X. So literally that same value, same function named C with a vertical or horizontal bar drawn across it. And we generate that average cost function, that C bar function, by taking the original function and dividing it by X. So our average cost function will be 945 plus 20x plus 0.03x squared divided by X. The difference between C and C bar is that C is giving us the total cost. So if we plug in X equals 100, we get the total cost of producing the first 100 items. If we plug that into C bar, the average cost function, what we're finding is the average cost per unit. So if we plug in 100, whatever value we get, that's approximately what we're spending on each of the first 100 items to get that total cost that we could find with C of X. In part B, we want to find the average cost per unit when 1,495 units are being produced. So we'll enter our average cost function. And evaluate that for X is equal to 1,495. And I'm going to try that again because it did not like something about my input. In this case, we get 65.4821, or approximately $65.48. Again, what that's telling us is that at this production level, the average cost per unit is $65.48. So it's costing us $65.48 to produce each unit if we averaged our total cost across all of those items being produced. Now we want to determine the end behavior of the average cost function. We can do that in Symbolab as well by asking for the end behavior of our function C bar and it'll tell us that as x approaches infinity, f of x is approaching infinity, and as x is approaching negative infinity, f of x is approaching negative infinity. The second half of that doesn't have any practical meaning for us because production can't dip below 0, but what we do care about is the end behavior on the right that tells us that as x is headed to infinity, it used f of x, but we know that that means C bar of x is headed to infinity, and then we want to interpret that end behavior. So as production increases, average cost per unit will continue to increase. Which makes sense. As we continue to produce more, costs will continue to go up. In example 9, now we're given a rational function that represents the number of employees for a new company where T represents the number of months after the company is created. We want to first find any horizontal and vertical asymptotes for this function. We can do that by asking Symbolab for asymptotes for this given function, 79 plus 96t divided by 6 plus 3t. And we have a vertical asymptote at t equals -2, horizontal asymptote at y equals 32. Even though it told us y, in this case our y variable is capital N, so that horizontal asymptote would be 32, n equals 32. But this is the same thing as saying we have a vertical asymptote at x equals -2 and a horizontal asymptote at y equals 32. Our vertical asymptote doesn't have a lot of practical meaning in this case, but we can provide an interpretation for the horizontal asymptote. What it's telling us is the model predicts that the company will have a maximum number, or I should say a maximum of 32 employees. So if this model is valid, as time continues to go on, so as t approaches infinity, n, number of employees, approaches 32. So even though more time is passing, that number of employees won't exceed 32, or isn't likely to given this model.